Introduction to Apache Spark, the next generation big data tool. So guys, let's start the session with the agenda. We'll start with need for Spark in the industry. Then we will introduce Apache Spark. We'll discuss its features and architecture in great details. Then guys, we'll talk about RDD, an abstraction in Spark. Transformation and actions, these are the two operations. Spark execution model, end-to-end execution and data flow. Then guys, we'll talk about Spark ecosystem. So let's start with need for Spark. Why Spark? Guys, in the industry there is a need for general purpose cluster computing system, as MapReduce limited just to batch processing, Apache Storm limited to stream processing, real-time streaming, Impala or These limited to interactive processing. On the other hand, Neo4j and Giraffe, they are limited to graph processing. So guys, for each and every requirement we need to use a specialized system, which is very costly. For MapReduce, I need a different team. For Storm, again a different team. Impala, Neo4j, for each and every technology I'll be needing different resources as well as developers. So guys, this is very tough to manage. That's why industry is demanding a general purpose system that can handle all the requirements. So guys, there is a need for a powerful engine that can process the data in real time as well as in batch mode. There is a need for a powerful engine that can respond in sub-second and perform in-memory analytics. Apache Spark, a powerful open source engine, provides real-time streaming, interactive, graph, in-memory as well as batch processing with speed, ease of use and sophisticated analysis. Guys, Spark is capable to handle real-time requirements. If I highlight real-time streaming requirements, Spark can handle interactive requirements. Spark can process graphs. Spark can process the data in memory. It can handle batch processing as well. So guys, this is exactly the component what industry was looking for quite long, a general purpose cluster computing engine. So guys, what exactly is Apache Spark? It is a lightning fast general purpose cluster computing system. Apache Spark is the most active component in Apache repository. Guys, today more than 70% of big data users are using Apache Spark due to its generality and speed. It is one of the favorite tool for big data developers as well as data scientists. Let's proceed ahead. Introduction to Apache Spark. Apache Spark is lightning fast cluster computing tool. It can process the data at lightning fast speed. It's a general purpose distributed system. It also works on a cluster. Guys, pretty important fact that took Spark to the limelight. It processes data up to 100 times faster than MapReduce. Spark is written in Scala, a functional programming language. Guys, by the way, the latest trend in the industry is from the object oriented programming. Again, we are moving towards functional oriented programming. Spark provides APIs in Scala, Java and Python. If you are a Java developer, you can go ahead with writing the code in Java. If you are a Python developer, no need to learn other language, go ahead with the Python. But recommended is Scala. Guys, Scala is a pretty nice language. Like if I compare Java with Scala, in Scala the same code can be written in 10 lines, which in Java we need 100 lines. It can be integrated with Hadoop and can process existing Hadoop data. Actually, guys, in the industry, we use Spark on the top of Hadoop. Let's proceed ahead. Okay. If I talk about history, Spark is not actually developed at Apache, it was developed at UC Berkeley in 2009. In 2010, they open sourced Spark. After almost 3 years, they donated it to Apache in 2013. And in 2014, it graduated to the top level project. Guys, it set new world record in sorting in 2014. In upcoming slide we'll discuss about that as well. With that, it actually came in limelight in the industry, and it became the most active project at Apache in 2015. Let's proceed ahead. Apache Spark features. Okay, let's discuss one by one. Speed. Guys, Spark is very fast as compared to MapReduce. It's 100 times faster in memory, or if you are using disk mode, it is up to 10 times faster. We'll discuss about it, what is in memory, how we can keep the data in memory. We'll talk about that in upcoming slide. But yeah, from the perspective of speed, it is lightning fast. Ease of use. Guys, Spark provides the APIs in Java, Scala, Python, and apart from that, you don't need to handcode each and every operation. Like if you want to do filtering, there is an operator available. If you want to do join, there is an operator available. They are, let me tell you right away, guys, there are more than 100 operators available, for which in MapReduce we needed to write codes by hand. Low latency. Guys, Spark process the data pretty fastly. It's pretty low latency system. Unlike the MapReduce, which was a high latency system, it processes the data in real time. It can integrate it to Hadoop. Guys, again, this is an important point, as world's most of the data is available in Hadoop, so all these systems must provide integration with Hadoop. So Spark can process existing Hadoop data and can write data back to Hadoop. Rich set of operators. So guys, as discussed, there are more than 100 operators available, which you can directly use for all the common requirements, whether it is reduce, whether it is reduce by key, whether it is as discussed filter, join, Cartesian, union. Operators are already available. Fault tolerant. Guys, fault tolerant is today's need. Without fault tolerant property, the system can't be accepted in the industry. Like in the night, if you put data to be processed, and you are expecting on the next day morning it will be processed, when you come back to office and you'll find, oh, there was some issue, some error, some hardware issue, some software issue, due to which your job failed and it wasn't able to restart itself. Again, you need to restart manually, you need to find the fault by yourself. No, not at all acceptable. Guys, today all these systems, whether it was MapReduce or Spark, they are highly fault tolerant. They heal themselves. Generalized execution model. Guys, MapReduce was pretty specific to map and reduce. Here we are not limited to just MapReduce. It's generalized. If you want to use map, use map. There are different operators available. Flat map, map partition. Tons of other operators are available. Whichever you want, you can use. So it's a generalized model. You can handle different types of requirements as well. You are not just limited to batch processing. You can handle batch, you can handle real time, you can handle interactive, you can handle streaming, you can handle graph, you can handle machine learnings. All these different type of workloads Spark can handle very well. Let's proceed ahead. Spark in limelight. Guys, today Spark is in limelight and there are reasons for the same. Let's understand the same. Guys, there is a short record, like let's firstly talk about a little bit about history. In 2008, Hadoop MapReduce defeated supercomputer in sorting. At that time, guys, Hadoop was the fastest system available on the planet. But guys, Spark defeated MapReduce like anything. Let me show you the fact how exactly MapReduce processes the data, or MapReduce sorted the data. Guys, MapReduce sorted the data in 72 minutes on 2100 nodes. On the other hand, Spark sorted the same volumes in 23 minutes on 206 nodes. The number of nodes is merely 10% of MapReduce and time taken is 1/3. Guys, after seeing this fact, industry has started investing in Spark quite heavily. They've invested millions of dollars in Spark. They have using it heavily in their different projects. So guys, if we discuss the sort in more details, the data size which was used in MapReduce and Spark both was around 100 TB. The time taken by MapReduce was 72 minutes. On the other hand, Spark took merely 23 minutes, 1/3. Number of nodes, MapReduce uses 2100 nodes. Spark merely used 206 nodes. Number of cores, in case of MapReduce it was 50,400 physical cores. In case of Spark it was merely 6592 virtual cores. Spark testing was done on Amazon AWS. MapReduce testing was done in-house at Yahoo. Cluster disk throughput, in case of MapReduce it was 3150 Gbps. In case of Spark it was merely 618 Gbps. Network, both of them had almost similar network. In MapReduce dedicated 10 Gbps and in the Spark virtualized 10 Gbps. So guys, the resources that Spark got was merely 1/10 of available to MapReduce. Still it excel like anything. It draw industry attention and became the most popular big data project, big data engine, big data solution. Let's proceed ahead. Hall of Fame. Let's talk about few insights. Guys, currently the largest cluster on the planet is at Tencent, which is having 8,000 nodes, more than 8,000 nodes. So guys, a single largest intake of one day, again at Tencent, more than 1 petabyte per day. Longest running job at Alibaba, 1 week on 1 petabyte plus data. Largest shuffle at Databricks, 1 petabytes. Most interesting app, it is at Jeremy Freeman. They are mapping the brain at scale. So guys, these are the few facts again which is making Hadoop in limelight. Let's proceed ahead and talk about Apache Spark architecture. Guys, Spark's architecture is again similar to Hadoop. It works in master and slave fashion. Let's discuss it. Okay, guys, we have two types of nodes in Spark. One is the master node, which is the manager node, and another is slave node, which are actual worker nodes. Master assign the work, slave does the same work. Guys, on the master we have a daemon called master. A master daemon runs on master node and worker daemon runs on all the slave nodes. So guys, master's work is management, monitoring, maintenance of the complete slaves, assign work to them, keep track of the same, and workers keep continuously be working on the work what master has assigned. Let's proceed ahead to Spark architecture, a basic Spark architecture, guys. As discussed, we have master, and slave. So a user, if he want to submit his work, if he want to process the data, he will develop the work, he will develop the job, he will develop the application and submit the same application on the master. Master will divide the work and submit it to all the nodes on the cluster. So guys, all these slaves are doing sub work. So in ideal condition, guys, you can imagine it like if we are having 100 slaves, each and every slave is doing 100th work. So guys, in this manner, Spark enjoys distributed computing, parallel processing. Parallelly, hundreds of machines are working rather than one machine is working. If there is 100 machines, so 100 machines are 100 times faster than that single machine. So guys, this is just a very basic architecture of Spark what we discussed. With time we will drill down in great details. Let's proceed ahead. Okay, there is a very important term in Spark that's called RDD. Guys, RDD is a basic abstraction in Apache Spark. Let's discuss it in great details. RDD. Let's firstly talk about its full form. Resilient Distributed Data Set. So guys, if we just try to understand the name resilient. Resilient means fault tolerant. If data is lost, it will be recreated automatically. If there is any failure, whether that is hardware level failure or software level failure, it will be recovered automatically. The next word is distributed. Guys, your data is distributedly stored. Data is distributedly processed. As discussed in previous slides, guys, Spark also enjoys distributed computing. One of the main reasons why Spark is lightning fast is distributed computing, distributed processing, data set. Data can come in from different data stores. So in upcoming slides we'll discuss that it can actually take the data from any of the data sources. Now guys, if we talk about RDD in a little more details, this is my data. As a cloud, I have mentioned that external data store. I'll read the data in form of RDD only. Just make a note, in the RDD session, guys, we will discuss these things in great details. What exactly is transformation, what exactly is action, what exactly is even external data store. We'll understand it in great details. But currently understand, we read the data in terms of RDD based on our requirements, based on the business requirements. We will transform the data. That will create another RDD, transform the data, create another RDD, and we perform action operation. Action is again another operation that generate the final result. Again, write the result to external data store. So Spark can read the data from external data store, process it in terms of transformation and action, and write back to external data store. RDDs are the fundamental unit of data in Spark. Guys, if you can understand RDD, you can, frankly speaking, crack any Spark problem. It is the core abstraction. We understand the data only in terms of RDD. We process the data only in terms of RDD. We write the data back again in the terms of RDD. We cache the data in the terms of RDD. It enables parallel processing on data sets. Your RDD, guys, just to understand RDD, it is a distributed collection. So say for example, if your file is stored somewhere in HDFS and if you want to create the RDD, yes, you can create, and your RDD is representing all the blocks of the file. It's immutable, recomputable, and fault tolerant. Immutable means unchangeable. Recomputable means it itself can recompute itself on data loss. And fault tolerant, handle the failure quite easily. We'll discuss all these three terms again in upcoming slides. Now, important point guys, during Spark programming actually we perform operations on RDD. What a Spark developer does, he performs operations on RDDs. Means overall during this Spark session we need to learn how to operate the RDD, how to run different actions and transformations on RDDs. So guys, we have two types of operations as discussed: transformation and action. Actually guys, in this section we are discussing quite basics of RDD. There is a dedicated section of RDD. A complete 2-hour session will be there for RDD. There we'll discuss it in great details. Let's proceed ahead. Okay, let's talk about RDD operations. So guys, there are two types of RDD operations. One, transformation. What do I mean by transformation? Create a new RDD from the existing one. Example, map, filter, join. So guys, this is your base RDD. This is your base RDD. RDD means collection, a data structure. This is your base RDD. If you perform any transformation, it will create a new RDD. Say, simple example, filter. You are having a file of size 100 TB on the top of which you have created the RDD. So now you want to filter the records based on say time. You are interested in only specific years records, say of 2010. So you can run the filter operation, filter transformation, and it will generate another RDD. Now the new RDD is having only the data of 2010. Another operation that we are having is action. Guys, it returns a result or write it to store. Guys, actions is simply to understand it generate the final result. Action generates the result. For example, count, collect, save. So this is our RDD, and if you perform any action you will get the final result, which you can either read yourself or write it to storage, data store. Let's proceed ahead. Okay, this is a little important. Spark context. Spark context is an object. Every Spark application requires a Spark context instance. A Spark context we define in the driver program. It is the main entry point for a Spark application. Your Spark context interacts with the cluster manager. What is cluster manager? We'll discuss that also. Spark context specifies how to access the cluster. Using Spark context we can control the applications, and even RDDs are created using Spark context only. So guys, if we concentrate here in our driver program, we will be having a driver method or main method. There we will create the object of Spark context. It will interact with the cluster manager for the resources. Cluster manager, guys, manager who keep tracks of all the resources, like how many cores of CPUs are available in the cluster, overall cluster, how much memory is available in the cluster, how many executors are there in the cluster. So all the information it is having, and it allocates the resources. So Spark context firstly interact with the cluster manager and get the resources. Like I want these containers where my executor will be running. So let's concentrate here. These are the worker nodes. I'm showing two worker nodes here. So guys, in the worker node, executor is going to run. Look at it. This executor will be running inside the JVM, and there will be multiple tasks running inside the executor. Look at it. In both the executors, we are running the tasks. All the things are configurable. Like currently I'm showing 2 tasks. More than 2 tasks can also run. We'll discuss in advanced sessions how to configure them. And one more thing, that is called caching. That is again quite important property, quite important characteristics that Spark is having. It can cache the data. It can keep the data in memory. So overall, Spark context, the main entry point of Spark application, interact with the cluster manager, get the resources, and process starts. Like your process starts in the executors. Executors are having tasks that will process the data. Tasks are the fundamental unit of execution. I think guys I am drilling down in more details. So regarding tasks, executors, there is a dedicated session again. Let's proceed ahead. Okay, Spark execution model. This is very important slide. Understand this carefully. Guys, the developer, this is our developer, suppose he will develop the application, he will develop the program, he will develop the driver program. As discussed, we will be needing Spark context object, the main entry point of Spark application, which can interact with cluster manager. So let's concentrate here on Spark context, which is interacting with the cluster manager. Guys, let's firstly have a look at the cluster. So guys, on the cluster we are having HDFS, that is your Hadoop distributed file system, that is having data nodes, data node 1 2 3 4, and data nodes are there. Data node is a slave of HDFS. On the same machine we are having worker, that is the slave of Spark. So data node is the daemon of HDFS and worker is the daemon of Spark. So on the same cluster where your Hadoop is running, on the same cluster we are running Spark as well. So I'm showing you the picture of a specific worker. A cluster manager will interact with the worker node and get the resources. So you want say 2 gigs of RAM, 1 core of processor for the executor. Okay, it will provide you the executor that will run in a JVM. So guys, here we will be having tasks, just we discussed it in previous slide. So these tasks are the fundamental unit of execution, and guys, by default one task processes one HDFS block. So for the guys who are not aware about HDFS blocks, again in the upcoming slide we'll discuss it. Block, you can understand, is a part of file. It's a chunk of your file that is in HDFS, that is called block. So guys, in the Spark execution model, developer develops the program. In the driver program we are having a Spark context object which will interact with the cluster manager, get the resources on the worker nodes, on the slave nodes, and process the data there. Whatever data is available on this particular data node will be processed here. Whatever data is available on this data node will be processed here. Alright guys, let's proceed ahead. Let's talk about the next line in our driver program, that is an RDD. Using the Spark context SC only, we are creating the RDD. Create the RDD, that is ultimately an abstraction of Spark. Spark programming means performing several operations on RDD. Look at it, what we are doing, performing filter operation, then caching it, then counting it, mapping it, and so on. There are several operations. So guys, if we talk a little bit more about RDD, resilient distributed data set, these are very important properties of RDD. It's immutable data structure, immutable, unchangeable. It's an immutable data structure. RDD is distributed data structure. Guys, we do have controlled partitioning. It's fault tolerant. RDD itself is fault tolerant. In memory, guys, that too explicit. Based on our requirements, we can keep the data, keep the RDD in memory. If we don't want, don't keep. It is having rich sets of operators. Like guys, we discussed few operators: filter, count, map, flat map, reduce. These are the operators. So guys, that's the basic of RDD and Spark programming model. Without Spark context and RDD, we can't really process the data. Let's proceed ahead. Let's talk about Spark ecosystem. Guys, till now whatever we discussed is about Spark core. Spark core is the main Spark engine. You can understand it like as a kernel of Spark. Spark core is the kernel of Apache Spark, which provides actually all the capability like fault tolerance, like distributed processing, in-memory processing to Spark. Now, if we talk about the ecosystem component, guys, the very first component we have in the picture is Spark SQL. It's the Spark SQL that enables users to run SQL query on the top of Spark. You can run your SQL or HQL queries directly on the top of Spark, but as soon as I take the name SQL, guys, you can only handle structured or semi-structured data with Spark SQL. Spark SQL today, guys, is one of the most popular SQL engine in big data. It is far ahead of Hive, it is far ahead of Impala. Let's proceed ahead. Next component is Spark streaming. Guys, it can handle live streams. What do I mean by live streams, guys? As and when data is generated, like currently your data is generated on your application server. Yes, at this point of time, whatever data is generated, it is processing the same data. Although we need to collect that data using the Flume, using Apache Flume, we can collect the data in real time. And Spark streaming can process that data in real time. So Spark streaming actually, guys, internally convert these streams into micro batches. The next component is MLlib, machine learning library. Guys, MLlib machine learning libraries are used by the data scientists for the advanced analytics. Developers also uses it for the advanced analytics. Like guys, if I give you one example, like guys, all of us are using Gmail, so automatically few mails are categorized in spam section, few mails goes in promotions, few mails go in updates, and so on. So who does this? Automatically your machine does this. Guys, machine become that much intelligent that it itself is categorizing the mails. Machine itself is that much intelligent that it itself is taking the decision. So guys, machine learning is used where developers can't handle all the possibilities. So we train the machine. How exactly we learn ourselves? We train the machine and then we can use those algorithms. Let's proceed ahead. Guys, the next component is graphics. Graphics enables users to handle the graph processing at scale. It is a special purpose engine where we do have a relationship in the data, like commutative or associative relationship, like A is related to B, B related to C, C related to D, B related to E, something like that. We can represent our data in terms of graph, and if we want to process that data, their graphics comes into the picture. So if we talk about real life use case, like on LinkedIn, if A is connected to B and B is connected to C, A and B are first degree connection and A and C are second degree connection. Or we can take the example of Facebook, friends of friends on Facebook. So guys, such type of requirements can be handled quite efficiently with the help of a graph engine like graphics. Now that's it about the complete ecosystem, guys. Now you'll be surprised to see that there is nothing called a storage system with the Spark. Spark is just about computation. It's a storage layer, you can see it's blank. Spark is dependent on third-party storage system. The most popular storage system is HDFS. Apart from it, Spark can natively connect to HBase, Cassandra, Amazon S3, and so on. Let's proceed ahead. Let's talk about this ecosystem in a little more details. Start with the Spark core. Guys, Spark core is the execution engine for Spark platform. It is a generalized execution model to support a wide variety of applications. Spark SQL. It enables user to submit SQL or SQL queries on the top of Spark. It also provides the engine for Hive data to run unmodified Hive queries up to 100 times faster. Spark Streaming, a powerful interactive and analytical application across streaming data. Guys, you can process the live streams without any latency. MLlib, a scalable machine learning library that delivers both efficiency and high quality algorithms. Graphics, a graph computation engine built on top of Spark that enables users to process graph data at massive scale. So guys, that's it for the introduction to Apache Spark. If anybody is having any questions, any doubts,